Okay, so we're back to verify the identity. Okay, so we look at this. It looks like the left-hand side is more complicated, right? Okay, so I'm just going to write it out, though, so I can have a little more room. I'm just recopying this. And I'm saying, this looks like a mess, Put all those negatives in there. But we're going to be able to simplify it into cosine theta minus sine theta. Okay, so we see that we have a lot of negative thetas, right? So we're going to use our even odd identities. So how will we write that? That'll be a little bit tricky here. So let me show you a way that you can do that. So the reason it's tricky is because in the numerator, I don't have sine of negative theta. I have sine squared of negative theta. I can write that as sine negative theta squared. I can write it like that. We don't usually write it that way because we usually use the shorthand notation. But in order for me to explain this, what's going to happen, I think you need to see it this way. So minus, and then I'm going to do the same thing here with the cosine. Okay? In the denominator, those are straightforward. So I can use the idea sine of the opposite of theta is equal to the opposite of sine theta. And I'm also going to use cosine of the opposite of theta is equal to just cosine theta. So we've got that the sine is an odd identity and the cosine is an even identity. Okay, so over, let's see, the opposite of sine theta, and then it's going to be minus. Now that minus sign is right here. That didn't change, okay? Cosine theta. So we'll write it like that, okay? So it still looks kind of messy. Sometimes it looks messier before it gets simplified. Now we're going to apply those same two identities in the numerator in those brackets. So I'm going to have the opposite of sine theta squared minus cosine theta squared over, and I'll just write it the opposite of sine theta minus cosine theta for now. Okay. In the numerator, what's going to happen? Well, when you square that, it's going to be positive. So you're going to get sine squared theta minus cosine squared theta. So maybe you knew that already, but I just wanted to show you where that's coming from. And then in the denominator, I'm just going to write minus sine theta minus cosine theta. But we're not done. Sometimes you have to scroll back up. Okay, what am I trying to get? I'm trying to get this. Cosine theta minus sine theta. Okay, remember that. All right. In the numerator, though, that's the difference of squares, right? So remember when you had a squared minus b squared? That was equal to a minus b times a plus b. Oh, I usually do the plus first. A plus b, a minus b. Doesn't matter which one you do first. Okay, so we can do the same thing here. We're going to have sine theta plus cosine theta times sine theta minus cosine theta. So I'm factoring the numerator. I'm also going to factor in the denominator. I'm going to factor out a negative 1. So I get negative 1 times sine theta plus cosine theta. Now, you may have noticed on this problem, and this happens on some of the identities that we're verifying, this had a numerator and a denominator throughout, right? So far, we've always had a numerator and a denominator. It's a little tricky to line those up, and you might be tempted to try to go sideways, but please don't. Please work down the page. It's just a little tricky to write it. Okay. Well, good news. Something cancels. So the sine theta plus cosine theta cancels, and we get this. So we have sine theta minus cosine theta over negative 1. But, you know, you can think about, well, I want to multiply by negative 1 over negative 1. I'm not sure how you want to write this, but, or you just think about taking it up into the numerator. But then that would give you negative sine theta plus cosine theta. And then you just have it over 1, so you don't need that. And then you can rewrite that as cosine theta minus sine theta. That's what we were going for. So we're done. So you may write it out a little bit differently, but those were the ideas to use. There might have been other ideas. That's just the way I did the problem.